Video 3-8, see checklist for when to watch it. This is about finding the second derivative implicitly. So implicit differentiation is when it's essentially, it's a form of doing chain rule, except you do chain rule on everything, on every term. And you know that you've got to do it. Sometimes they won't tell you to do it. Like here, I'm implying that we're doing it because of the topic up here. But like if you look at the problem, they say find this in terms of x and y. This is d squared y over dx squared. I think that's how you say it. This is Leibniz notation for y double prime. So this is the second derivative. That's what that is. It's Leibniz notation for the second derivative. And I know without being told I've got to do implicit differentiation, I know I'm going to because I'm finding a derivative of y with respect to x because it's y over x in the Leibniz notation. And the x's and y's are mixed together. Y is not solved for. Okay, so I go like this. I go d dx xy plus d dx y squared equals d dx 1. So I'm taking the derivative of all of these. For this one, I've got to do product rule. So it's going to be d dx x, and then I just bring down the y, plus just bring down the x, d dx y. And then this part, I can just do this at this point, I guess. Or no, maybe I'll just bring it down. So plus d dx y squared. So I haven't really taken any derivatives yet on the left side. The right side I'll just do now. That's 0. The derivative of any constant. Okay, so the derivative, so the derivative of x is just 1 times dx. And then the y comes down. And then plus this x comes down, and the derivative with respect to x of y is 1, and then this is times dy dx. And if you see a faster way, if you notice that you can skip steps when you're doing this, that's fine. And then plus, so the derivative of y squared, that's like the derivative of the outside function, which is 2y, times the derivative of the inside function is dy dx. Every time you have like d something dx, that's the derivative of the inside function. And when you're doing implicit differentiation, you think of the inside function as the variable. That would be the innermost function, equals 0. Then, wherever you see a dx, that's just a 1. So that's just a 1 right there. Okay, so I'm going to change dx is to 1 because that's just what it is. The derivative of x with respect to x is just 1. And then the dy dx is I'm going to switch to y prime. All right, so this is y plus x y prime plus 2y y prime equals 0. All right, so I've got 2 y prime terms right there. This one is not a y prime term, so I'm going to get it over on the other side by subtracting it. So I end up with xy prime plus 2y y prime equals negative y. And then I'm going to factor out a y prime, and I'm left with x plus 2y on the inside equals negative y. And then I will get that y prime is equal to negative y over x plus 2y. But they're asking for the second derivative of y with respect to x, so I need y double prime. So to get y double prime, so for y double prime, I've got to take the derivative of that thing, so I've got to go like this, take the derivative of this entire thing there, which is a quotient, so I'm going to need quotient rule. So the quotient rule, I kind of did this yesterday, but it's we usually set it up like this, or we used to. Just a minute. Over. Okay, so here's quotient rule. It's f prime g minus fg prime all over g squared. But I'm going to set up this same thing using Leibniz notation. So I'm going to have d dx of the top function times the bottom function minus the bottom function times d dx of the top function. And then this is all going to be over the bottom function squared. All right, so here's negative y. Here's x plus 2y. Negative y, x plus 2y. And then down here is just x plus 2y squared. Okay, so let me move over here. No, I'll do it right below. Okay, so the derivative of y as like an outside function is just negative 1 times inside function derivative is that. And then I just bring down x plus 2y. All right? And then I'll do a plus y here. And then this one, this is the, so yeah. All right, so the derivative of, I gotta take the derivative of both parts here. So the derivative of x with respect to x is just 1, but then times dx over dx, plus the derivative of respect to 2y is just 2 times dy dx. Okay, and then this is all over this, x plus 2y squared. Now in the next line, this dx is just going to be a 1, and I will change the dy dx's to y primes. So this is negative y prime x plus 2y plus y 1 plus 2y prime all over x plus 2y squared. Now the problem is we're not done because they said in terms of x and y. So in terms of x and y means, you know, that you've got y double prime. So these are all y double primes. Means that you've got y double prime, but only in terms of x's and y's. So the only variables I see are x's and y's. I see y primes as well. So I don't want these y primes here. But that's when you ask yourself, well, what is y prime? So back up here to what we did in this step, we know that y prime is equal to that. So wherever we see a y prime, this is just going to go in for it. This part here, that's going to go in for y prime. It's going to be super messy. So finally, in the end, y double prime, which is the same thing as that, is equal to, it's going to be a mess. Okay, so in for this y, in for every y prime, I'm putting this. So I'm going to end up with a positive because I'm negating the fraction. So I'm going to end up with y, oh, this will be kind of nice, y over x plus 2y times x plus 2y over 1, I could put it. So that's, this comes down here. Oh, that'll be nice. Plus y, 1 plus, this will be 1 plus 2 times negative y over x plus 2y. And then this whole thing is over x plus 2y squared. Okay, I'm going to do a little bit of simplifying. So let me just move. That's ridiculous. But I'm just moving. I'm going to move this all the way up there. So I end up with y double prime equaling just a plain old y plus, oh, that should have been a 1. This should be a 1. I put down a plus. That's a 1. That's a 1 right there. Okay, so y double prime plus, or yeah, so y plus y 1 plus negative 2 over x plus 2y all over x plus 2y squared. And if you want to simplify more, you can. Like you could put, yeah, this might look better if it's y double prime equals y plus, I can see a way to make it even better, but y plus y 1 minus 2x plus 2y. So this here is the second derivative. All right, that is the second derivative in terms of x and y. Okay, guys, I'll talk to you soon. Bye-bye.